Hello everyone, welcome back to my channel, and in this video we are going to build a 4-bit adder. So we will be using this video is a continuation of our last video in which I built different logic gates like XOR or NAND gates. So if you have not watched that video, I will highly recommend you to first watch that video or any other video to understand the functionality of logic gates with their truth table. So in this video, I am going to build a 4-bit adder. So first we will build 1-bit adder, then I will connect a 1-bit adder to make 4-bit adder. So here is the table which we can follow to add binary digits. So if you don't know, there are only two binary digits 0 and 1, and if we add 0 plus 0, then carry will be 0, sum will be 0, and if we add 1 plus 0, then sum will be 1, and 0 plus 1 is the same result, 1, sum will be 1. But if we add 1 plus 1, then the sum will be 0 and carry will be 1. As we know, in there are only two digits in binary. 1 plus 1 is sum will be 0 and carry will be 1, because as we know there are only two digits in binary system. So we if we add 1 plus 1, it will not be 2, it will be 0, and the carry extra carry will be carried out to the next bit. I will explain this in depth in upcoming videos, but for now you have to understand this table only. So if we see this area, so if you see this area which is carry, and if we recall some knowledge from the last video, this is actually a value of AND gate. AND gates output 1 only when both bits are 1. So in A plus B both bits are 1, then output will be 1. But if we see these values, these are actually from our last video, which is XOR gate. And in the XOR gate, if we add same values, for example 0 plus 0 or 1 plus 1, then output will be 0. But if we add different values like 1 plus 0 or 0 plus 1, then output will be 1. So I am going to add those gates here, and then we can move to the next section. So this is a simple circuit in which we can add 4 bits, and the output will be 2. One will be for sum and another will be for carry. So to confirm our table, we can check this. If we input bit A and B 0 0, then output will be 0 and carry will be 0, as you can see here and here from the values are pins. So if we input A1, then sum will be 1 and carry will be 0. So upper pin is for sum and the bottom pin is for carry. So if sum is 1, then upper pin will light up, and if carry is 1, then lower pin will light up. And if we turn on second input, then carry will be also 1 and sum will be 0. But if we turn on both pin, then here you can see the sum pin will be 0 and carry pin will be 1. So this is simple circuit in which we can add one bit only. As I already told you in the early section of video, that I will connect for 1-bit adder to make 4-bit adder. So to do that, we first need to get 1-bit carry, which will, for example, if there is 1-bit adder, it will output 1 bit for sum and another bit for carry. Then we will get that carry input into the next 1-bit adder. So here I have added one bit extra for carry. So but we have to rewire some of the circuit. So here is an example in which I am adding 4 bits together, which are this and this, and this is sum of these 4 bits, and these are the carry bits. So this whole circuit represent 1 bit. So in these two, if we add these two, 1 1, then as we can see from this table, 1 1 will cause the sum to be 0 but carry to be 1. So this is 1 1, then we sum it, then sum will be 0 but carry will be 1. So sum will be shown here but carry will be here. So this carry is this bit which we will count. So this carry will we will add in next bit. So this extra bit which I have added here is for adding carry bit from the I have added an XOR gate here that will add carry bit to the output of this XOR gate. But we can also get carry bit from here, which we can check using this AND gate. So it will check if carry bit is 1 and XOR gate is 1 also, then so it will produce another carry bit, which we can see in this scenario the sum bit is going to be 1, and if we add extra carry bit which is this one, then the sum will be 0 and a carry bit will be moved to the next bit. So we can use AND gate to check that, and we can use OR gate to check if there is a carry from these 2 bits or this carry, then we will output that carry to the next bit, as you can see here from this pin. If you are thinking this is a very complex circuit, this is actually very simple. We have added 4 1-bit adder. So each 1-bit adder will add 2 bits. So what it will do, a bit from section A inputs or section B inputs, it will add these 2 bits and it will output a sum bit which we will show here, and an extra carry bit which we will pass to the next 1-bit adder. So here if you are thinking what is it, this is an extra carry bit that we can use to connect multiple 4-bit adder to make like a 8-bit adder or 16-bit adder. So the purpose of this output carry bit is the same, because this carry bit will output the carry to the next 4-bit adder. As you can see, this is very simple. For example, this 1-bit adder is adding a bit from here and here and outputting some, and same is doing here this 1-bit adder which is taking this bit and this bit and to sum and outputting its output to this pin, and then passing it carry to the next bit. So we can actually check it. For example, if we check this value 0 1 0 1, which is 0 1 0 1, and 0 0 1 1 1 1. So as you can see, the output is 1 0 0 0, which is like 1, which is this pin, 0 0 and 0. So we can verify this by comparing its value to this table, which we know that working right. As you can see, if we add 1101 to 0011, it will turn on the carry bit, because this the output of these two numbers is actually 5-bit number, but our this circuit is can only show 4-bit number. We can actually make a 8-bit adder by combining two 4-bit adder.